Hi, I'm Laura, and I'm an earth scientist. I study what Earth's warming might mean for Canadian Arctic glaciers and the rest of our planet. And the Canadian Arctic is my research lab. A glacier is formed from the accumulation of snow at cold, high elevations. Over time, the snow compresses to form ice that can then flow under the force of gravity down to lower, warmer elevations where the ice melts. You may have heard that the United Nations have a goal to keep global average warming below 2 degrees Celsius in order to slow down climate change. However, in the Arctic, we've already observed that temperatures have risen by more than 3 degrees Celsius since 1972. So why do I care about changing glaciers? Well, glaciers are huge reservoirs that provide water for ecosystems and human activities during the dry summer months. And with warming temperatures, increased glacier melt is causing sea level to rise. Scientists have been studying glaciers in the Canadian Arctic since the 1960s to understand how glaciers respond to changes in climate. This early research inspired me to work here at White Glacier on Axel Heiberg Island in Nunavut. This island is uninhabited and the closest communities are to the south, here in Grise Fjord and Resolute Bay. Ever since I started working on White Glacier in 2009, I have asked the question, how is the mass of White Glacier changing each year? Glaciers are too large to put on a scale, so how do you think we could measure glacier mass change? For a glacier, snowfall provides a gain in mass each winter, and ice melt leads to a loss in mass each summer. By measuring each part, we can determine the total glacier mass change. To measure the gain in mass from snowfall, we dig snow pits near the top of the glacier and analyze the snow depth and the snow density. We measure ice melt using metal poles that we drill several meters into the glacier surface. This metal pole was drilled into the ice 2 years ago. Before the summer melt, the ice surface was up here. And now after 1 month of melt, the surface of the glacier has melted down to here. By comparing these changes over many years, we can start to determine what aspects of climate lead to future glacier changes. There are, of course, some challenges to this work. It takes several airplanes, each one smaller than the last, to make our way to Axel Heiberg Island. It can be very cold, even in the springtime, and sometimes it is below minus 30 degrees Celsius with the wind chill. And the biting wind can make it hard to work with your hands. But we do our best and try and have some fun in the process. Our team is only in the Arctic for 3 weeks, and the rest of the time I'm analyzing our measurements at my computer. An important part of my research is sharing my data with researchers studying glaciers in different parts of the world. This way we can understand glacier change and sea level rise on a global scale. So now we're standing on the end moraine of White Glacier. That means that in 1960, and since the last ice age, White Glacier was here, and since then has moved all the way back to what we see in the background. So it's retreated almost 1 kilometer over the last 57 years. You might be wondering, what can I do? We know climate warming is due in part to human actions and the release of carbon dioxide from our industrial and transportation activities. So any effort you can make to reduce your use of fossil fuels and petrol products, including plastics, is a meaningful way to help mitigate climate change. But also, an important thing about being a scientist is communicating what you've learned. So today after school, go home and ask your friends and family what they know about glaciers. If you live in BC, see if you can visit a glacier near you and be sure to take some pictures. Some of the most important glacier data that we have is not from scientists, but collected from ordinary people who have taken photos of glaciers through time. Together, we can make a difference. It's like the old saying goes, snowflakes might be one of the most fragile things in nature, But just look what happens when they stick together.